We look at our towering skyscrapers and multi-lane highways and naturally assume we represent the undisputed pinnacle of history. This perspective is shaped by the conceit of the present, a psychological bias that leads us to treat the most accessible, most visible achievements of our era as representative of all human potential. In his 2026 book, Searching for Lost Civilizations, philosopher Boris Kriger argues that this confidence relies on overlooking our own historical blind spots. We study the thin, well-organized slice of the recent past and mistake that single shelf for the entire library of human experience. The academic establishment once dismissed the city of Troy as a metaphorical invention of Homer, a fairy tale for classicists to debate. That consensus lasted until Heinrich Schliemann ignored the experts, dug into a hill in Turkey, and unearthed the actual stone foundations of the city. More recently, the discovery of Göbekli Tepe demolished the standard model of civilizational development. These 15-ton limestone pillars were carved and erected by hunter-gatherers 11,000 years ago, centuries before the first evidence of agriculture or domesticated crops. We often tell ourselves that absence of evidence is evidence of absence, but that logic fails if the environment is actively destroying the record. If a civilization flourished and vanished in the deep past, what would actually be left for us to find? Evaluating the reality of ancient civilizations requires calculating the exact mathematical physics of planetary preservation. This is the Detectability Index, a rigorous mathematical tool Kriger developed to calculate exactly how far back in time our archaeological knowledge can accurately reach. It breaks down into 3 primary variables: material degradation, geological erasure, and search coverage. The first variable, material degradation, highlights a counterintuitive truth about our own era. The materials we rely on, steel, glass, and reinforced concrete, are exceptionally fragile over deep time. Without maintenance, a skyscraper's steel rusts into powder within centuries. Glass shatters. Within 10,000 years, modern cities leave no recognizable remains. In contrast, unmortared granite blocks can retain their shape for millions of years in dry climates. This reveals a core paradox. Technological advancement actually makes a civilization less likely to leave permanent physical traces in the deep geological record. The second variable is geological erasure. Earth is a relentless recycling system that actively consumes its own history through tectonic movement. At subduction zones, tectonic plates dive into the mantle, melting into magma. This annihilates surface evidence, dragging ruins into the planet's interior. Due to this conveyor belt, 70% of Earth's surface is completely recycled every 200 million years. Then we have the third variable, search coverage. Because of inattentional blindness, we often miss evidence simply because it falls outside our expected patterns or exists in regions that are difficult to scan. Tropical rainforests efficiently swallow massive, sprawling empires, hiding them from traditional ground-level archaeology. For centuries, the stone pyramids of the Maya sat mere meters away from explorers who could not see them through the dense jungle canopy. Our current certainty is based on a map where the majority of the pages have either been physically destroyed or remain entirely unread. When Kriger runs these variables through Bayesian models, we see that our detectability index remains high for the last 50,000 years. If a civilization comparable to ours existed then, our surveys would have found it. But look at the drop-off. Between 100,000 and 1 million years ago, the probability of finding physical evidence on Earth's surface plummets towards 0. This is the epistemic horizon, the hard limit beyond which the geological fog is too thick for our instruments to see through. In this dark zone, finding nothing tells us nothing. The silence is no longer informative. To bypass Earth's recycling machinery, we have to look toward off-world environments where perfect preservation is physically possible. The Moon acts as the ultimate deep-time archive for the solar system. With no atmosphere, no water, and no tectonic plates, the lunar surface preserves features for billions of years. A stone structure placed here a billion years ago would still be here today, barely altered. Kriger's framework isn't a claim that these lost civilizations existed. It is a demand for scientific humility, challenging us to admit the limits of our knowledge and finally begin the search in the right places.